this is chapter 2E, where we are now solving linear equations with brackets and pronumerals on both sides, okay? So previously in 2D, you just learnt the variables being on one side of the equation only. This time it is on both sides. Don't get too scared, it's pretty straightforward. You'll be fine. Now, hopefully, the goal for today is we are going to be able to solve equations by expanding them first, which is what I actually taught you already, so we don't need to cover this anymore. The main part here is point two. So to solve equations with variables on both sides by collecting the variables onto one side. So just remember that, okay? So we plan on moving the variables from both sides and turn it to one side only. And to do that, you'll just apply the inverse operation of that term. Now you can skip slide 3, slide 4, and slide 5. You'll be fine. The main point is right here. So if an equation has polynomials on both sides, collect to one side by adding or subtracting one of the terms. This is important. Okay, collect to one side by adding or subtracting one of the terms. Okay, that's the key point right there. I will show you what happens here. So I will actually just get rid of some of this. What is this stuff? No. Oh, edit text. So I'll use my example here as 3x plus 4 equals 2x minus 3. So I'll just rewrite this out again. Now just remember, the first step is to collect the the terms of the variables to one side. Now, last year when I taught you this, I always told you to put the variable onto the left side. It's just a bit more appealing to look that way, but you don't always need to do it. You can actually pick and choose whether you want to keep it on the right side or the left side. It does not matter, okay? But I think just for simplicity's sakes, let's just keep it on the left side, okay? Now, as you can see here, I have this 2x on the right side of the equation, and I need to move it over to the left side. I need to apply the inverse operation of this term right here. Now, looking at this 2x, do I see a negative sign in front of the 2 there? Not really, yeah? So, that would highly indicate that this is a positive or plus 2x right here, okay? So the inverse operation I am now going to apply is minus 2x. And I am going to apply minus 2x to both sides of the equation. So I will now show you negative minus 2x, just like that. Now the 2x on the right side just disappears completely because it turns to 0, yeah? 0 kaput. That's all it is. Now, whatever it is that I'm left with on the right side of the equation, I am going to write that down. So in this case, I have this minus 3. I'm just going to bring it down here. Okay. Now, the next tricky thing is figuring out what do I have left over on the left side of the equation. I have 3x minus 2x. So if you calculate 3x minus 2x, that's normally 1x, right? And in algebra, we never write the 1. So we're just going to keep it as the letter x in this case. So I have x here. I'm just going to get rid of this. So I have x here. And as you can see here, I have this plus 4 still. So I'm going to bring that down. This will now become x plus 4 equals to negative 3. As you can see, this looks very familiar with what you learned previously. So you are going to apply the same rules as before. You're solving for x, so you need to isolate it. You can easily get rid of this plus 4 on the left side by minusing 4. So when I minus 4, That disappears to zero, kaput. I'm only left with x on the left-hand side. And on my right-hand side, I'm just going to apply -3 minus 4 in this case, which just ends up being -7. Okay, that's all it is. Now, let's go through some of these examples together. I have 5x minus 2 equals to 3x minus 4. Now, the first step is to always bring your variables over to one side only, or your terms with the variables to one side. I am going to move this 3x and move it over to the left-hand side. Now, let's just check what inverse operation I need. With my 3 here, I don't see a negative sign, so I can assume that this is a plus 3x. Hence, the inverse operation I shall apply is minus 3x here. So when I apply minus 3x to both sides of the equation, I am typically left with 5x minus 3. Oh no, I'll just write this a bit neater. Minus 3x like that. Minus 3x like that. Disappears. I am now left with 2x minus 2 equals to -4. Because 5x minus 3x is just positive 2x right there. I have my -2 on the left-hand side. That does not change, so I've just brought it back down. And then -4 here just gets brought down here to the right-hand side, okay? So nothing's changed. All I've done is just remove the 3x, and only the x's have changed so far. Now, as you can see, this looks very familiar with what we're used to. I need to isolate the x now. So get rid of everything else. Apply the inverse operation of this -2 of +2. So when I plus 2 to both sides of the equation, all I'm left with is this positive 2x here. Because the -2 disappears, it turns to 0. And then I have -4 plus 2. -4 plus 2 just equals to -2. And then the final step here, I need to get rid of the coefficient of 2 attached to this x here. I am now going to divide by 2. So when I divide both sides by 2, all I'm left with is x is equal to -1. Because 2 divided by 2 is just 1. And then I have a negative number divided by a positive number, which is just a negative. Hence, x is equal to -1. Now, if you wanted to check if x equals to -1 is correct, you can do what I taught you previously by substituting this into the original question. So substitute the -1 into where you see the letter x, figure it out, and both sides of the equation should equal the same number. Okay. Now, I have 3 bracket 2x plus 4 close brackets equals to 8 open bracket x plus 1 close brackets. Now, remember previously, I always taught you to expand the brackets first before you do anything. So why don't we just do that, okay? Let's just expand the brackets. Make life easy for us. So I'll just do this a bit quickly because I believe a lot of you should be comfortable with expanding now, but I'll just talk through it. So I'm going to take this number 3 in the left-hand side of the equation and multiply it to the 2x and this plus 4 here. Now 3 times 2x is 6x. 3 times 4 is 12. That's done. Equals to 8 times x is 8x. And then 8 times 1 is just 8. Okay? Now, let's move the variable over to one side. I'm going to move this 8x over. So as you can see, there's no sign there originally. So I'm just adding in a plus there. The inverse operation we shall apply now is -8x. So when we minus 8x on both sides of the equation, I have 6x here minus 8x. All I'm left with is -2x because 6 minus 8 is -2. Now, plus 12 stays the same. because nothing's been changed to that. And then this minus 8x here, this turns to 0. This turns to 0 right there. And all I'm left with on the right-hand side of the equation is this positive 8. Now you just carry on with what you're quite used to, okay? Isolate the variable of x. As you can see here, plus 12, I can easily get rid of by minusing 12. If I do that, I'm left with negative 2x equals to negative 4. Because 8 minus 12 is negative 4, that's why. Now over here, my final step, I need to get rid of this negative 2 attached to the letter x. So I am now going to divide by negative 2. When I divide by negative 2, all I'm left with is x is equal to positive 2. The reason why it's positive is because I have a negative in the numerator, which is negative 4. I divide it with negative 2. So the two negatives just cancel out to make a positive. And then I have 4 divided by 2, which is 2. Okay? So x is equal to positive 2 in this case. Now, just work on this by yourselves. If you need help, ask me. I'll double check your answers for you. And these are the questions that you can do. Okay? So make sure you ask questions when you need help. Please don't just rely on your friends. I am here to help you. If you need any additional support, I am at school every Wednesday after school. So, yeah, feel free to come and see me. Just tell me beforehand so that I can actually like rock up. Just because of the fact that if nobody tells me or if I don't plan anything, then I am just going to be doing my own business. Okay, take care.